everyone. Yeah, hopefully it's 3 p.m. Yeah, so my name is Tianhui and I go by Rosey. I'm a second-year master's student in the Data Science for Public Policy program at McCourt. So I'm delighted to attend the local system and data panel at the GGCI Summit today and share my research on lead certification and local neighborhood attributes represented by Airbnb listings in San Francisco. Yeah, so today's agenda is kind of divided into 3 sections. First, we will discuss the connection between lead certifications and the local community. Second, we will compare the Airbnb data and lead projects in San Francisco. And finally, we will present the results of our predictive model. So at the left-hand side of this slide is actually lead projects on the DC campus of Georgetown. Yeah. So I would like to start us off with a quote here. From my viewpoint, urban growth should not come at the expense of community character, as growth should be in tandem with the local community. And on the other hand, LEED certifications is a symbol of sustainability achievement and leadership. And our research is aimed at to uncover how LEED certifications relate to the local community in San Francisco. And we use the Airbnb data to represent local neighborhood attributes and use the attributes to predict LEED certifications. The prediction models should perform well if LEED is deeply rooted in the community. So my initial exploration compared Airbnb data and LEED projects in San Francisco geographically. So as you can see, the density is actually very different. So the Airbnb listings is kind of everywhere in San Francisco, but like the projects in the LEED directory is only like concentrated on the right corner of financial district and South of Market. So if we are aggregating data on a community base of the neighborhood boundaries, the number of observations can be very different. So I actually come up with a way around. So I found the top 5 closest Airbnb listings to each building in the LEED directory. So we can change the analysis from the neighborhoods to actually to each LEED building. So I also look at the Airbnb listings price around buildings with different certification level. And this exploration shows the listings around LEED Silver projects actually has a wider price distribution. So among the less than $1,000 per night group, just make it more sensible. And this could be caused by the number of LEED Silver projects being with much larger number than other levels, or because like LEED Silver projects are located at places where the wealth gap is larger. So that's actually my first insights there. And with the exploratory data analysis results in mind, let's dive into the predictions. In the first section, I construct models to predict the true or false value of whether the project is certified, use Airbnb descriptions. And on the left is a word cloud of description. And the words here actually have like really similar weights. You can see like apartments, accommodates, and so on. And regarding the model performance, the ROC curve, like right there, it's just a validation curve. It's just a validation methodology. And with higher AUC representing a higher performance score. And actually, in this case, we can see the KNN with like 4 neighbors has a better performance than the naive base, which has a 0.64 in our model. But actually, it's not very like satisfying because like a 0.5 representing a coin flip, and our model is just slightly better than that. So moving on to the predicting the project's certification with Airbnb listings neighborhood overview. And actually, you can see there's some interesting pattern here because we see like area, art, and bar is on the top list. So they occurs more frequently. And actually, I think that kind of makes sense because people are trying to find places where there are interesting things going on. And our model performance didn't perform as well as the model before because they have a slightly lower score. But in this case, naive Bayes has a slightly better performance than the KNN with 4 neighbors with 0.58. Yeah, and then I tried to build models to predict the certification levels, use other Airbnb listings attributes, and control for lead attributes. Models I included here are decision tree, random forest, and also like k-nearest neighbor. Yeah. After I ran the models, I found that the decision tree with the default number of maximum depths performs the best, and the whole ranking is listed here. So you can see like the mean test score and the standard deviation of the test score, and higher score just indicates better performance. Yeah. And judging from the decision feature importance, which is kind of like which factors like has a higher weight in the predictions, you can see the gross floor area and lead rating system version is the top 2 on the list, which is kind of makes sense because like it's related to the lead building itself. But interestingly, following that are the Airbnb listings price, average minimum nights the next year of the Airbnb listing, and also like total number of reviews and review scores. But these numbers are significantly lower than the attributes attributes related to the lead building itself. So actually, in conclusion, while the impact of the lead projects on the local community remains unclear, as we can see, there's a huge gap between attributes related to the Airbnb listing and lead building. We can still relate to the local residents attributes such as real estate prices, lease terms, and popularity reflected by the review score. And these could be topics for further exploration. And that's basically my research.
That's
Thank
wonderful.
you.
Thank you. Thank you. Great. What's that? Oh, Josh just did. Yes. Yeah, you're up, right? Yeah.
All right. For those of you who are hoping we could end with a bang, this might not be the project for you, but we will see. So hi everyone, my name is Josh Rosen. Like Rosey, I'm also a second year in the Data Science and Public Policy program here at the McCourt School at Georgetown. And my project is titled Analyzing the Impact of Bikeshare on Traffic Injuries, Evidence from the Boston Metropolitan Area. And so the best place to start is probably by defining the problem. And we can do that broadly by looking at the threat that traffic injuries pose on our cities, or more relevantly, we can look at that as it relates to micromobility and to bike share. As many of you probably know, bike share is near ubiquitous, micromobility is near ubiquitous in a growing number of cities. And I'm sure you see it every day, bike docks and e-scooters litter the streets of our cities. But nevertheless, the impacts of these projects are not very well understood. And I mean that pretty broadly. We don't really know what micromobility is doing in our cities. And so as a result, I attempt to find out what the causal relationship is between bike share and traffic injuries. All right. Aha. Okay, so and to do that, and to answer this question, I use data from the Boston metropolitan area's blue bike share system, which just like Capital Bike Share or City Bike is a dock-to-dock bike share system that launched in 2010 in the Boston metropolitan area. And between 2010 and 2014, the program went through its initial expansionary phase, and it launched in 4 cities: Brooklyn, Boston, Cambridge, and Somerville. And then actually in the next 6 years after that, the program would launch into an additional 6 cities. And so I attempt to operationalize this program's staggered launch date to construct both a traditional and an instrumented difference in difference estimator. And so I use city level traffic data from 2010 or traffic injury data from 2010 to 2014 to construct a treatment group using those 4 cities that were part of the initial expansionary phase. And then I also used the 5 of the 6 cities that it would later launch in to construct a control group. And we can do that because since the program launched in those cities later, it's a fair assumption to make that they probably have similar land use and zoning and demographic characteristics that we can use it as an okay counterfactual for the original treated cities. And so we can see in the first model up there, that first specification, Y sub IT is the number of traffic injuries in city I and month T. And T is our indicator variable for if it's a treated city, and D sub K is our indicator for how many months it's been since treatment. And I also include at the end city and month level fixed effects. But then, as I'm going to discuss later, it becomes pretty relevant that we also need a different approach, and that's why I include this instrumented difference in difference specification. And so here that allows us to look at what impact the variation in number of bike share rides has on traffic injuries. And we instrument for bike share rides with that interaction term for if a city has been treated and if it's part of the treatment group. And then so using that instrumented term in the second stage of the regression, we get the beta coefficient, which is going to report our causal interpretation for how the variation in bike share rides impacts traffic injuries. And I think I report that logged in my results, but we will see. All right, so for the initial results, as I'm sure many of you have probably guessed, it's hard to detect anything with an initial difference in difference estimator. And there are a lot of reasons for this, but the big one is that bike share stations are removed during the winter. So if we're just looking at months since treatment, we're not actually detecting what's going on. So we see no effect. Using the instrumented approach, though, we can get a little more granular, and this is the second stage results. And so in the first column, I report just that beta coefficient from that specification I showed, and it is logged. And it also has city month fixed effects. And then in the second two columns, I also include city-specific linear and quadratic time trends, and I include these to allow for unobserved city level city injury propensity to trend in both a linear and a quadratic fashion over time. And so, it's statistically significant. Technically, it might not be substantively significant, but we see that a 1% increase in the number of bike share rides produces 0.06 fewer injuries. And so that's up for you to decide what 0.06 of an injury really is. And there's that substantive significance problem. And before I move on, I actually want to touch on some threats to identification, which I'm sure you're thinking of as well. The first one is possible spillover effects created in situations where the stable unit treatment value assumption is violated locally. And alternatively, it's also possible that cities constructed pre-treatment infrastructure. So in other words, bicycle infrastructure may be, it may induce additional bike share trips, and that may be correlated with both treatment status and traffic injuries. So just a very classic endogeneity issue here. And so due to these threats to identifications, I'm also going to attempt another empirical strategy, but don't really get your hopes up too much because we run into some more issues there. All right, so here I wanted to glean a rudimentary but hopefully informative view of the causal relationship between bike share and traffic fatalities, or excuse me, traffic injuries, using the forecast error of a hierarchically estimated Bayesian autoregressive moving average model. That is a mouthful. And so here the autoregressive term is estimated hierarchically, so we can borrow strength from other groups in the data because we have multiple cities. So if we just want to predict Boston, that autoregressive term can jump between groups and borrow strength. And so here Y sub T is our traffic injuries per month, and A sub T is our autoregressive term, and it's given a normal prior, and it can jump between groups to borrow strength. All right. And so looking at the results, we also see some issues here. So on the left, we can see that the blue line is the hierarchically estimated model. And I also include the true injuries that happen in green, which I hope you can see. And in black is an ARMA 1-1 model, which is just a more basic way to do a similar model as a comparison. And also on the left, or on the right, I showed the ARMA 1-1 model, the credible intervals, just as like a comparison. And so what we see here is that the hierarchically estimated autoregressive moving average model is massively overfit. And you can see that because at month 10, when it starts predicting out into future dates after treatment has been introduced, the forecast error jumps by a huge amount, which indicates that our model is just poorly parameterized. And probably has bad priors on it. So this approach doesn't get us a very good causal estimate either. And so to conclude, I think I set out to solve a causal question. I didn't solve it, but nevertheless, I think it's really important to understand these threats to identification for people who want to into the future tackle these questions. And then in terms of Bayesian time series modeling, it's really important to have well-informed and computationally feasible priors on all your model parameters, which is really the issue we ran into with the time series approach. Thank you.
That's great. Thank you. Chris, you want to take a whack at this one? Yeah.
Okay.
So I'm wondering to what degree the problems you were running to and that what you were just discussing now. How it seems to me that you're trying to study something with a fairly limited database necessarily, right? There's only so many observations given, the nature of the phenomenon you're looking at with specifically with Bikeshare, right? And time frame also. Do you have any sense of how much of this is that as opposed to, specification and other things like that?
Yeah, no, I mean, that's a great point. The reason I used the hierarchical estimation, so the autoregressive term could borrow strength from other groups, is because there wasn't a lot of prior data. And because we had so limited prior data, it was very hard for the model to learn on what previously happened. So that obviously plays a huge role in it as well.
Just to follow up, and to be a little less technical about this for some people who, didn't really enjoy instrumental variables as much as some of us may have, and don't spend as much time with difference in distance estimation. Fundamentally, what is it that interests you about this, and what if you had, if you got a definitive conclusion, and let me say, we always say, no bad results, just more data, right? So, but if you got some kind of definitive conclusion, what would it mean in practical terms that other people would care about who otherwise don't care about this stuff?
Sure. Yeah, that's a great question. I bike to campus every day, and I think a lot of people do. I think anyone who stepped on an e-bike feels like that's the future of transportation in urban America. But that being said, there's a lot of heterogeneous findings on what the impact when we enroll these programs in our cities, what actually happens, because there's theory on both sides. There could be more bike riders, which means more potential for danger, more car accidents, or it could create the safety in numbers approach, which we've seen in some theory literature, where there's more bikers, so cars start to learn their behavior better, and we have fewer injuries. And there's also could be a substitution effect where fewer drivers mean more bikers and less traffic injuries. So there's just all of these different causal pathways pointing different directions. And I know there are definitely policymakers out there who see bike share programs and say we should, do something like this because it's a danger to our cities. But this is an opportunity to really show that that's not true, and having these programs would create safer, better cities.
Very good, thank you.
So actually, a similar question sort of to you in terms of what is driving your interest in the question, and what kinds of policy implications are there for policymakers?
Yeah, actually, like this research idea come from my internship with like a real estate consulting firm, because like LEEDs buildings are like at the center of the discussions like in a lot of markets. And I think after the COVID pandemic, a lot of discussion is centered around like work from home and all these like what's the future of the office buildings. So I kind of want to look into like how the LEED certifications really impact the local community. And I thought of like different ways to represent like the attributes of a community. And I really want to find something like how people are talking about where they are living and how these office buildings are having impact on their daily life. So like the Airbnb data like just catch my eye because they have like review scores and all these. So I think this is like a good start point for us to look at these interactions between the LEED certifications and the local attributes. But I think like one of the issues is like how granular we have to look at these things. And I think there definitely can be spaces for improvement.
Great, and then sort of for both of you, just sort of in my professorial mode, I would say, it's great to see negative results being presented or results that like don't work out, because that's the majority of what we do, right? It's not all going to be publishable and have significance and like be ready, right? And we learn from it, sort of no matter what. And so I think sort of that's really great. I think that one of the things that we need to do is as professors, and I think especially on the technical side and in economics, you don't do a good enough job of helping people explain what all this means to the folks who haven't taken those same kinds of classes or took them long ago. In our case, it's right. And so that's one of the things I'd say when you try to present this kind of information, to take a little bit more time, sort of in terms of explaining sort of what it is you're trying to get at and what some of the assumptions are that are underlying it, so that your results will be more powerful and more understood. But I think it's great to present all kinds of results, not just sort of the amazing things with higher squares and that are going to get published.
So I'm going to make the opposite comment and ask you what data are you looking for that you could not find?
Yeah, kind of like related to my previous comments. I think like it's really hard to think of a way to characterize like what people are saying in the about the places they have their daily lives in. So I think a better way is just to have a survey, like a field trip thing, like to ask people like, how do you feel about this office building? Like, is there any like, have you noticed the LEED certifications, this concept? And yeah, like kind of that way, but it's not like a really approachable thing from the research perspective to have the enough data. And I think it's there are more resources needed for the survey. Yeah.
That's a really good question as well. I think the big one for me is because I was using difference in difference, and it's tough to have like a counterfactual. If there were monthly updated covariate data from like the city of Boston, for example, if they had kept data on the monthly number of, metro riders or something to that, it would have been helpful to do a synthetic difference in difference model, where I could have just used a synthetic control group. And that would have made creating a counterfactual much easier.
Yeah, no, this is really great. And I think thank you to both of you for those excellent remarks. I'm really going to geek out here. I'm sure everyone reads the Provost blog. And the Provost had a really eloquent, as he does, blog about finding new data sets and how research shows us, the boundaries of available data and the gaps in data that we really want to know, but that we don't have access to because it doesn't exist. And I think these, to your point about different disciplines coming together and different methodologies coming together to think about urban research. I mean, these are kinds of conversations that we need to have, and we need to get more comfortable having across research methodologies in order to understand, how we can understand cities better.
And I'd say also in terms of data sets that certain people might have that we don't know that other people have, right? And so there might be somebody who actually has that data that you need, but connecting with them and figuring out where that would be and how it would be tagged and all of those kinds of things sort of is something else that sort of we need to get better at. And technology should allow us to do that now, right? And I think we're starting to get some of that, but not nearly as much. And a certain group like ESRI has tried with some of their observatory stuff, but it never really took off. Partly because everybody was terrified that they were just going to monetize it somehow and lock us out of it, right?
And I was going to make that exact point, and that is that to make a painfully obvious point is that so much of the data that we might want to have access to is proprietary and not available, which kind of triggers a whole other series of very interesting policy questions around, and Chris, maybe you can reflect on this a little bit about, what data local jurisdictions require as part of various permitting processes, and what we're comfortable with remaining in the private realm.
Yeah, I think this is really a big, issue for research broadly. And that's the big change. If I think about like where we are now from where, say, when you and I were in graduate school, right? And even before that, there is all kinds of data available now that didn't exist. And I'm thinking, for instance, in your work, whether some of the data that's available from groups like streetlights, if you're familiar with that, a lot of it based on cell phone movement and all that, would be something that could be useful. And I don't know what your answer is, but the answer might be yes, it would be useful. And the immediate question would be, well, how would I get access to it, right? So there's more data now available than ever before, and it's less public than ever before, because basically among the things that have happened over the last 4 decades is the retreat of the government from research, and specifically from providing data, funding data and making it available. So census has in many ways less information than it used to have, and more of it is owned privately as intellectual property, which is really counter to the mission of academic research and the whole idea that we want the information around so everybody can mine it and engage with it, and have the same base of knowledge. So I think this is actually a big, the short-term question is, how can I get somebody to fund my access to this proprietary data package, right? The bigger question is, how do we have a society that continues to be at the forefront of learning, research, and the development of new knowledge, if we don't have broad access to this kind of information that in fact is being generated, but is now constrained from people really interacting with it on a regular basis?
So I have not yet formally introduced, but I will now, Vice President of the university, Chris Murphy, who's here. And I wasn't going to pick on you, but I am now, because Chris was very instrumental in forming the DC Open Data platform. And Chris, I'm wondering if you would just kind of reflect on the conversation that we're having, given that you were in a decision-making position on these kinds of questions, and then also any broader reactions to what you've heard today.
Thank you. Thank you for letting me be a fly on the wall until you called me out. So I've been at the university for a number of years, but my career has primarily been in government, and I had a senior role both at HUD and at DC government. And so I've been really, and especially my time at DC government, I was particularly interested in data. And I guess I would make an observation. I'd love to hear any reactions to it. I was really pushing the city to be more, sort of try to be at the cutting edge of what kind of data we shared. On the theory that sort of if you build it, they will come, and sort of interesting, people will find it and do interesting things with it. It seemed to me, in reflecting on why it didn't sort of blossom the way I thought it would blossom, a couple things. One, there's an economy of scale problem, I think, in that to spend the time to do the research, there aren't that many people who are interested in one city's data set on one thing, right? And so you kind of want to have like 10 cities data set on the same thing, right? To sort of justify it, and you want to be able to compare cities. So that struck me as a challenge. The other challenge that when you sort of think about that is cities tend to collect data differently. And so it's you get an apples and oranges to bananas to hamburgers problem. And so there's all kinds of challenges. So it's really interesting to see what people like you are doing with the sort of parochial, for lack of a better word, sort of way cities might be capturing data or thinking about. But I'm curious to know if that resonates with people at all. I guess and I had a question for you, Josh. Because I thought it was interesting, and I'm sorry it didn't, show something mind-blowing, but it was still fascinating nonetheless, I thought. I guess one question is, I'm curious to know, just a very simple question, because I'm not smart enough to do the data. I'm assuming there's some sort of like self-reporting in terms of the injuries. Is it a self-reported data, or is it some hospital collection, aggregate hospital data that categorize things or so. So that would be one question. And I guess, do you think that impacted at all? Like maybe people in Boston are less, they're hardier, so they tolerate getting hit by a bike, where people in DC are whiny and they want to scream to the rooftops, you know? So does that have anything to do with it? And then secondarily, I wonder if you've given any thought to a correlation, not necessarily between a bike share model, but a bike, how many bike lanes there are. So, and maybe that's been well researched, but if you, I guess the question I think about in DC a lot is we build out a bike network also on the theory that if we build it, they will come. And there's not a lot of data yet that shows it's come yet. We built a lot of bike lanes, and if you stood next to a bunch of them and had a counter, you wouldn't, you know, you wouldn't be overwhelmed. You wouldn't be, your thumb wouldn't hurt by the end of the day from all the clicking. And so I guess I wonder if there's any connection between, does that impact? Does it, or is there some way to show that maybe bike lanes bring it down because they're actually lanes and people aren't driving in the road? Or just curious to know if you have any reflections on that.
Yeah,
That's a lot to throw out there, but.
So for your first question, there definitely is an answer to this. I'm just not aware of the answer. But I imagine it's self-reported because if it were only accidents that led to, or injuries that led to hospitalization, that would like be a whole other thing, basically. And then in terms of the bike lane point, you're exactly right. I think that's like a huge point of endogeneity in this identification strategy. I think a lot of the research that has looked into how micromobility impacts traffic injuries has shown that as well. There's one study that looked at the staggered rollout across several countries in Europe and cities in Europe. And it found that cities that had more infrastructure were more likely to see traffic injuries decrease when micromobility was reduced or was introduced. And then the opposite effect happened when there wasn't a lot of infrastructure. So it's very much tied into what infrastructure exists.
And I just wanted to make a similar kind of comment on your project, and that and make an observation, and that is that we actually don't have very much information at all on the relationship between offices and residences. I mean, that's at the foundation of your work, is trying to understand quantitative relationships between those two. And we have transportation information, but we have very little knowledge associated with how people live and how people work, and the kind of performance data associated with those two things, which is really interesting, actually. Yeah.
In the case of transportation, disproportionately vehicle.
Yeah.
We have very poor data on pedestrian activity, which is mostly related to.
Yeah. Yeah.
And we're only starting to get these bicycle data. By the way, in places we do have counter places like my community, and I disagree with the statement. So go hang out. Let's see what I'm saying. That's impressionistic, right? You actually do need systematic data, and there's only a few places where some communities are only going to have to commit to this, so they got counter all over the place. And that meant that I could walk to a place and answer somebody who said, "Well, it doesn't seem like thing," and say, "Well, there were 1,200 people on that stretch yesterday," you know, because again, we don't have the same commitment to collecting that data, like all the other modes, which is fundamental to all the questions we're trying to ask, to cut across the built environment and human activity.
Yeah, that's great. Let's just give both Rosey and Josh a huge round of applause. And what I want to do now is have a short but comprehensive and insightful conversation about the whole day. Yes. Lucas, please.
Just to the whole conversation about data, right? There's all kinds of problems. It's not reported. We can't compare between cities. And I run into this problem because I'm interested in kind of comparative research, comparative political economy. So I'm often like my presentation, comparing across regions, right? So when looking at like economic data in Germany and the US, there are different ways of reporting this data. There are different classification systems. Even in the US, we've had different classification systems. So I think we also need to just be aware that sometimes we need to take 2 steps back and also consider other methods like qualitative methods to really contextualize this data and kind of establish causality in different ways. because there are so many limitations, which we just talked about for 10 minutes, and that often gets lost because we get really excited about data and statistics.
Other general reflections? Yes, please. Yeah. Speak into the mic.
Hi, I'm Raj. I'm a DC resident. I went to the campus maybe 8 years ago, St. Elizabeth. So regarding GSA, if I could call it tax, something like that. Do you know in which bid GSA pays some kind of amount in DC?
You're asking the wrong person.
Sorry.
Yeah.
I'm not actually sure how the other. I'm not sure how the other.
Chris, can you start us off? Just a quick reflection on what you heard today.
I feel like you've heard a lot from me today already. Well, I'm really struck by the interesting questions being asked, and the comment that was made earlier on one of the earlier presentations, I think applied generally, which is I'm really impressed by the degree to which folks were able to pose a real research question, a definable question, which I think is often, in advising students, like one of the bigger challenges that people often start off with the kind of, big and feeling they have to get bigger and bigger. And really the best thing to do is to make it smaller. And the fact that when you do that, you often can get real insight into bigger questions. And that, that's really a key. And I think there are two different, kinds here. You pointed earlier to the fact that a few of these are framing, and that's really, one aspect that's important. And, others are specifically looking for data, and sometimes you get a good answer, and sometimes what you get is the data is not telling me anything, but that's important as well. But in both cases, it really depends upon being able to start off knowing what it is you're trying to address, and having a research question that you can at least easily express what the question is. The explanation, everything you do, it can get very complex, but you need to at least be able to say, this is a clear thing I'm trying to address. And I thought everyone today did a really good job at that. So I was generally very impressed.
Okay, thank you.
Just that I think that we see insights from a wide range of methods that are used to talk about and explain and explore questions. And I think that that's really important, and that we need to respect all of those different types of approaches, and not only sort of say that, well, you must have quantitative data all the time, or in other fields, quantitative data is viewed as worthless, right? And so combining these different methods, though, is where I think a lot of the potential strength going forward is going to be, across methods, across disciplines, and across generations.
I just want to thank everyone. This has been a wonderful afternoon. There's something that we've done recently in the initiative, which I'm really excited about, and that is that we've formed a formal partnership with the United Nations Habitat. We're now recognized as one of their global partners. It's a small room here. We've had a kind of wonderful, kind of intimate afternoon here. But I don't want anyone in this room to underestimate the power that we have to elevate ideas up and meet many challenges that cities are facing and grappling with. And to me, that's the excitement of the initiative. And it was expressed here this afternoon. So I want to thank everyone, and please help yourself to additional refreshments. And that concludes the 5th annual Student Research Summit. Thanks, Chris.
Yeah.